Okay, in this short video, I'm going to talk about the thin layer chromatography, or TLC as it's called. TLC is basically, you can consider it to be an analytical technique which essentially helps us in determining the composition of your sample. Chromatography, recall, is something that comes from, that has Greek roots actually. Chroma stands for color in Greek. So earlier it was thought that it could only be used to determine and figure out the mixtures which were colored in nature, but as we now understand, we can detect the presence of any component by taking advantage of either a UV light or maybe a stain or just the thermal index of that particular compound. Now, when you come into the lab, you will find these TLC plates and they will look like these. These are pre-cut for you, and we are going to spot the two components of our mixture that we are going to run a column chromatography on at a later time. So my two components are orthonitrophenol and metanitrophenol, and we are going to spot those on TLC plates. So I have here my two unknowns. This is the 2-nitro, or the orthonitrophenol, and the second one is the metanitrophenol, and I'm going to go ahead and spot these on the TLC. Now, a couple things before you begin. It's important to realize where exactly are you going to spot that. So first things first, you're going to have to draw a line right from the edge of this TLC plates, and I would suggest maybe use about 1 to 2 millimeters distance. Keep that. Okay, so like I was telling you, here's my TLC plate, and I have basically put in 3 little notches, 3 little sections where I'm going to spot the sample. You have to do this with a pencil, not a pen, because if you use a pen for this, when you actually carry out and run the eluent through that, the ink is going to bleed as well. So you don't want to do that. So let's go ahead, spot our first sample, and I'm going to do that right here at spot number 1. Just 1 dot is enough, and then I'm going to do a co-spot for that as well. 1 is for my first component, which is 2-nitrophenol, and 2 is for the second one. Notice I haven't taken a whole lot of the material in. I have taken very little of the sample, and I already had a second spot, so just 1 spot right there, and then do a co-spot. You don't want to use the same capillary again and again because you don't want to, of course, cross-contaminate that. Now, once it is set, you just let it dry for a little bit, and then you set it to elute. In this case, your silica gel, which is on top of this glass-bagged TLC plate, that is going to be considered as the stationary phase. The silica gel on that, which is our adsorbent material, and I'm going to use in this case 5% ethyl acetate hexane to elute the sample. Now realize, based on what you have, as you elute your sample, the samples are going to run at a different speed. So one will travel faster than the other one, and that has got to do with the polarity of the structure. So one of the questions, if you notice in the post lab, we'll talk about based on the structure, how can you predict which one is polar or not, and you would be able to see for now which one is polar. Again, recall here I have spotted spot number 1 was my ortho product, co-spot was the combination of ortho and meta, and the second one was the meta by itself. And now I'm going to simply put it on into a TLC jar, which can either be an actual TLC jar, or it could actually be a beaker with a watch glass. It could be something like that. In that, I have already poured 5% ethyl acetate hexane. Notice there's a little bit of there's like a little filter paper that's inside, and that is basically to help the TLC stay where it is, and also help in generation of that equilibrium. So all I'm going to do is, you can use a pair of forceps for this, or you can just hold it by the edge, and in one quick motion you want to hold it, you want to let it run. I am going to keep it loosely covered so that so that you do not you are able to generate that equilibrium, and you do not disturb that equilibrium. So we are going to simply let it run till you get the eluent all the way up to maybe 2 millimeters or 3 milliliters from the other edge. So you want to try to run it as far away as possible. The longer it runs, the better it is, the better separation you're going to get. Okay, so as you can see, my eluent is rising and it's going through the TLC plate, and it has gone up to probably about like a centimeter away. So I'm still going to let it run. Like I said, the farther that it runs, the better separation we would have, and so we'll have a better picture of the RFs. Now you might ask, what is an RF? Realize every component is going to travel based on the polarity in that given eluent. So greater is the polarity, that would mean that that particular material is going to stick at the bottom of the TLC plate and is not going to actually go all the way up. Whereas if you have somewhat of a non-polar component that is going to travel faster and is expected to have a higher RF, also referred to as the retention factor. So you can actually determine for each of the components, you can actually determine the RF, which is basically the distance that is traveled by that component divided by the distance traveled by the solvent. And so this number will always be a fraction. It can never be more than 1. And realize that it gives me information about the polarity and the non-polarity. So again, non-polar components will have a tendency to travel faster. Polar components will have a tendency to stay closer to our origin, which was the line that I had drawn earlier. So also realize that the RF of a component is going to be a fixed number irrespective to the length of the plate. So right now I'm using a 7 centimeter plate, but if tomorrow you decide to use a bigger jar and like 10 centimeters, since it's a ratio, that really is not going to change the RF for our component, for that particular compound. So I think it's kind of now ready to be removed from the TLC jar. So I'm going to just use a pair of forceps and take that out. And before your solvent front kind of dries up, mark where the solvent was at, and I'm going to use a pencil. Thank you. So I'm going to mark where the solvent was, and you can hopefully see here, you can hopefully see slightly there's a little bit of yellow right here, which is one of my components. That is the first component, and recall the first component was where the orthonitrophenol was placed. So I'm just going to put a little bit of a circle around that, but I am going to stain it later in KMNO4 and show you what that looks like, so that you can actually see where that yellow spot is and how we can determine the RF. So we're going to go through the calculation in a bit. Okay, so hopefully you can see the little yellow spots for the orthonitrophenol, but it's kind of faint and it's difficult to see that, and you probably cannot see the meta anyway. So I'm going to just stain that in the TLC jar, and let's see how that shows up. Look at that. You can see, is there a paper towel? If I just remove, the excess, you hopefully can see that the first spot right here, which was the ortho, went all the way up till this point. There is nothing in here. We only have a bottom spot, And the third one is the co-spot, which contains both. So that is a good sign, because in this TLC that tells me there was no cross-contamination that was ongoing in this particular case. So I can use this TLC, the results from this TLC, I can use that in order to carry out my column chromatography. So again, we were able to run a TLC between orthonitrophenol and metanitrophenol, which are the two components of my mixture. And in the next video, we are going to take a look at how we would be able to separate those in a preparative sense from each other, and then be able to carry out the measurements of some physical parameters like melting point, for example, to be able to tell for sure that what we began with and what we end up with is the exact same thing. Okay, so going back to this TLC, one thing that I would want to highlight as to how you can calculate the RF, again, you're going to essentially measure the distance from the origin to the central point of this spot, and you're going to divide that by the total distance that was traveled by the eluent. So in this particular case, let's take a ruler, and if I can set this right, the other way around. It's about 2.1 for the top spot, and the total distance that it ran was about 6.4. So that would mean 2.1 divided by 6.4 divided by 6.4, and that is going to give me the RF of that top component, which is the orthonitrophenol. Notice this one barely moved, and so the central point of that shows me in terms of numbers. If I want to put a number to that, that's going to show me 0.3 on the scale, so that will be 0.3 divided by 6.4, and when you find out the ratio of that, that will give you the RF of the second one. So hopefully you can realize from here that orthonitrophenol is much more non-polar as compared to the metanitrophenol. Now it's your job to draw the structure for yourself and explain to yourself why is it that one is more non-polar than the other when both of those are basically isomeric molecules. Now you might wonder what is a good solvent or a good eluent, and just a reference point for you, a good solvent would be considered that which has an RF of somewhere ranging between 0.25 to 0.35, because at the end of the day you want to be able to run that on a column, so your results that you get on a TLC are essentially extendable to a column chromatography. And understand the power of this technique. If you're running a reaction and you don't know whether the reaction has gone to completion or not, you can simply take a TLC in the middle of the reaction and be able to tell for yourself if you're seeing a new spot of the product or not. And so you don't have to run the reaction 1200 different times. You can actually monitor the reaction as you go and be able to predict whether the reaction is complete or not. So TLC is a very powerful analytical tool for us to be able to determine what's going on with the reaction. Or if you have an unknown sample, you would be able to comment on the purity of that sample as well. Now, I do have a question for you. If I were to run this exact same TLC in just hexane, let me use a pen, hexane. Which is C6H12, 14, 12 will be cyclohexane. So if you take hexane or cyclohexane, something which is non-polar, what would you expect? What would happen to this RF? Alternatively, if you were to run this thing in ethyl acetate, which is a polar solvent, CH3, C double bond O, C2H5. How do you think the polarity is going to change in that case? I want you to mull over that while I set up the column for the column chromatography.